Welcome to the Deep Dive. I'm really glad to be here with you, our curious listener, as we unpack the most impactful updates from the AWS cloud. This past week, basically September 8th to September 12th, has been just buzzing with innovation, and we've sifted through, well, all the announcements to bring you the crucial insights.
Indeed, quite a lot to cover. Our mission today is really to distill the essence of these updates, focusing on what actually matters for technical pros like you.
Yeah, cut through the noise.
Exactly. We'll highlight enhancements that can, significantly impact your architectures, streamline your development workflows, maybe boost your operational efficiency. Time to level up on the AWS landscape.
So let's dive right into this week's highlights. We've got everything from AML advancements, core infrastructure stuff, and critical networking and security enhancements, too.
Sounds good. Let's see how these pieces fit together.
Okay, first up, AI and machine learning. For those of you really pushing the boundaries here, AWS is rolling out some seriously powerful tools, things that really caught my eye, actually.
Absolutely. And what we're seeing, I think, is this dual focus. It's not just raw compute power, though there's plenty of that for these massive models.
Right.
But it's also about significantly enhancing the developer experience for AI workloads, making all that power, more accessible.
Okay, so let's talk specifics. Amazon SageMaker notebooks, now supporting the EC2 P6B200 instance type. I mean, on paper, it sounds like an absolute beast.
Oh, it is. It absolutely is. These instances are a genuine game changer, especially if you're working with large foundation models.
Okay.
You're getting 8 NVIDIA Blackwell GPUs. That's 1,440 gigabytes of high bandwidth GPU memory, plus 5th-gen Intel Xeon processors.
Wow.
But the real insight here isn't just the specs, it's how this performance jump fundamentally shifts the economics and the timeline for experimenting with large models.
How so?
Well, teams that previously faced, maybe prohibitive costs or just huge timeframes for iterating on these massive models, they can now accelerate their R&D dramatically. It's not just about up to 2x better performance compared to P5. It's about unlocking breakthroughs that might have been just impractical a few months ago. You can interactively develop, fine-tune large language models, mixture of experts, multimodal stuff, write in JupyterLab or Code Editor, much more efficiently.
That's fascinating. So beyond just raw speed, are we talking about enabling totally new approaches, things that maybe weren't feasible before, even for smaller teams?
Precisely, yeah. While the raw power definitely screams large foundation models, what it effectively does is sort of democratize access to this level of compute.
Right.
Smaller teams can now burst into this capability for, say, a critical fine-tuning phase or maybe rapid prototyping multiple architectures before they might have had to queue up jobs for days, maybe weeks. So it lowers the barrier to entry for really cutting-edge generative AI research and development.
And, with these intensive, expensive training runs, you don't want them lost to some unexpected hiccup. SageMaker HyperPod is introducing managed tiered checkpointing. That sounds, critical.
Vital, yeah.
This directly tackles one of the biggest headaches as AI training scales, that vulnerability to infrastructure failures.
Makes sense.
So managed tiered checkpointing is this kind of hybrid approach. It gives you both speed and durability. Frequent, lightweight checkpoints get stored in CPU memory. That's for rapid recovery from, transient issues.
Okay.
But then periodically more robust data gets persisted to Amazon S3. That's for long-term durability against bigger outages.
Gotcha.
This dramatically minimizes how much training you lose. It reduces the time needed to resume training from what could be days down to potentially just minutes.
Wow. Okay.
And it's configurable. It integrates with PyTorch's distributed checkpoint, available for Hyperpod clusters using the EKS orchestrator. So minimal code changes for some significant resilience. It's really about enabling more ambitious, longer training runs with greater confidence.
Okay. Now, for many developers, Visual Studio Code is like home base. It's where they live, right? Yeah. So now, Amazon SageMaker Unified Studio supports remote connections from VS Code. How does this fit into their workflow without, forcing a whole new way of doing things?
That's exactly the goal. It means you can keep your customized local VS Code set up, all your extensions, key bindings, preferences, everything. But you seamlessly access the scalable compute resources of SageMaker Unified Studio. Authentication's secure, simple, uses the AWS Toolkit extension.
Right.
The real insight here, I think, is how it streamlines that path from local development to scalable cloud infrastructure.
Right.
Whether it's data processing, SQL analytics, ML workflows,
Yeah.
developers don't have to choose anymore between their favorite local environment and cloud scale. They get both. They can maintain their existing workflows while tapping into these powerful back-end resources.
Speaking of workflow improvements, Amazon Q Developer,
Hmm.
that generative AI assistant, it's popping up in more places. It's now integrated with Amazon ECS for task definition editing, and it has improved assistance in SageMaker Unified Studio. How much, I guess, smarter is Q getting here?
Significantly smarter, I'd say, because it's becoming more contextually aware. That's the key.
Okay.
For ECS, Q Developer now gives you AI-generated code suggestions, explanations, even refactoring for task definition JSON right in the AWS Management Console. That's a huge time saver for container deployments.
I know. Yeah.
But the real leap, maybe, is for SageMaker Unified Studio, the Amazon Q Developer Chat and command line support in Jupyter Notebooks and Code Editor. It now leverages something called Model Context Protocol Servers, or MCP servers.
MCP servers, right?
Which basically means Amazon Q Developer is aware of your specific project resources, your data, your compute, your code.
Wow.
So it provides personalized assistance for data engineering, ML tasks, like really precise code refactoring or targeted troubleshooting. You get highly relevant responses that genuinely speed up your work, not just generic suggestions.
And sticking with AI, AWS launched a CloudTrail MCP server. Again, Model Context Protocol. This lets AI agents use security and compliance capabilities through natural language. That sounds like a pretty powerful shift for security teams.
It's a fascinating application, yeah. AI directly helping with security ops. Your AI assistants can now analyze API calls, track user activities, perform advanced security analysis across your AWS environment, all using conversational interfaces. The insight here is how much it streamlines investigations. You get direct natural language access to 90 days of management event history. You can run Trino SQL queries on CloudTrail Lake data going back up to 10 years.
Without custom APIs.
Exactly. No custom API integrations needed. It transforms reactive security analysis into something more proactive, intuitive, efficient, reduces the cognitive load on analysts quite a bit, I think.
Okay, let's shift gears a bit away from pure compute and developer velocity. Because even the coolest AI needs a rock-solid foundation, right?
Absolutely essential.
So let's dig into how AWS is hardening the network and security layers this week and improving operational visibility.
Yeah, and I think a crucial theme here, especially for anyone grappling with multi-account complexity, is that continuous effort. Enhancing security, providing deeper visibility, simplifying those complex networking challenges, especially in large-scale or regulated environments.
Right. So for organizations with these sprawling multi-account setups, Amazon ECS Service Connect now supports cross-account workloads. This sounds like it could tame some serious complexity for microservices.
It's a really significant simplification, especially for service-to-service communication in those complex setups. It integrates with AWS Resource Access Manager, or RAM, so you can now share the underlying AWS Cloud Map namespaces with individual accounts, OUS, even your whole organization.
Okay.
The insight is how this fundamentally changes things for platform engineers. They can use one consistent namespace to register services across all accounts. That drastically cuts down duplication, streamlines access.
And for the developers.
Application developers benefit hugely. They get a shared registry without having to worry about availability or synchronization problems. It just improves operational efficiency and makes scaling ECS workloads across different parts of the org much, much easier.
And for those managing truly massive, maybe global networks, AWS Direct Connect now supports 4-byte autonomous system numbers, AS numbers, for virtual interfaces. This feels maybe a bit niche, but for large enterprises, probably a long-awaited future.
Oh, it's crucial for them, yeah. Customers with complex multi-tenant network topologies, or maybe those needing consistent AS numbering across their entire global network.
Right.
The old 2-byte limit of about 65,000 AS numbers, that could become a real architectural bottleneck for the biggest organizations that have to use workarounds.
I can imagine.
With 4-byte AS numbers, you get the full RFC 6793 range. That's up to, what, 4.2 billion? It provides much-needed flexibility for these massive network designs, available globally, all Direct Connect VIF types.
So the insight is removing a scaling limit.
Exactly. It removes a critical scaling limitation, allows for cleaner, more consistent network architectures for the most demanding use cases.
Okay, Amazon CloudFront. 2 key updates here. eCDSA support for signed URLs and support for IPv6 origins. How do these fit together for content delivery?
Well, they represent a kind of holistic approach to modern content delivery, I think. First, the ECDSA support, that's elliptic curve digital signature algorithm for signed URLs and cookies, that offers better performance and security.
How so? Better performance.
Yeah, you get faster signature generation and verification, smaller signature sizes, which means shorter URLs, and equivalent security, but with smaller key sizes compared to RSA.
Okay.
This is great for high-volume stuff, mobile apps, IoT applications where, every byte and millisecond counts.
Makes sense.
Then, building on that, CloudFront now supports IPv6 connectivity all the way to your origin servers, so end-to-end IPv6 delivery.
Finally end-to-end.
Right. This helps meet architectural or regulatory needs, improves network performance for IPv6 end users, and crucially, helps address those IPv4 address exhaustion concerns for your origin infrastructure.
Right, that's still a thing.
Definitely. So the combined insight is really a more secure, performant, and future-proof content delivery strategy.
Okay, data protection. Amazon S3. GuardDuty malware protection has significantly expanded its scanning capabilities. This feels massive, especially with the explosion in large data lakes.
It truly is, yeah. This update raises the maximum file size limit for scanning from 5 gigabytes up to a substantial 100 gigabytes.
Gigs.
And it increases the archive processing capacity from 1,000 files per archive up to 10,000.
Wow.
So the insight here is it drastically reduces potential blind spots in your S3 storage. You get better protection for both large individual files and those big comprehensive archive collections.
Yeah.
Against malware, viruses, malicious code before they hit your workloads.
Bans automatic.
These enhanced capabilities are automatically enabled in supported regions. Now, of course, for teams with truly colossal archives like petabytes, this enhanced scanning also kind of prompts a thought about balancing protection with cost or just the sheer volume of alerts, right? Prioritizing scans effectively might become a new strategic task.
Good point. Okay, network performance monitoring, particularly across continents. Amazon CloudWatch network monitoring now gives flow visibility between AWS regions. That seems like a huge step for global application teams.
It is. It's about getting deeper, near real-time insights into your cross-region traffic. Flow monitors now give you visibility into network performance between compute instances, AWS services across the whole AWS global network.
And the key part.
The key is the Network Health Indicator, the NHI. It helps you quickly detect and attribute network-driven problems, whether they start in your local region, the AWS global network itself, or a remote region. And this covers public IPs and private traffic over VPC peering or transit gateway peering.
So it really reduces the guesswork.
Exactly. The insight is that troubleshooting global apps becomes less of a black box. You can proactively identify localized performance issues and dramatically cut down that mean time to recovery for your globally distributed services.
Speaking of security and observability, CloudWatch Observability Access Manager, OAM, now supports VPC endpoints. That sounds like a critical security boost.
It definitely enhances your security posture. It ensures all traffic between your VPC and CloudWatch OAM stays entirely within the AWS network. No traversing the public internet.
Right.
The insight here is mainly for organizations with really strict compliance rules or those running in highly private network setups. You can now set up secure, private, reliable connections to manage cross-account observability settings, links, even from VPCs with no internet access.
Using Private Link.
Yep, leveraging AWS Private Link security controls like security groups and VPC endpoint policies. It basically hardens your observability plane, making it just as secure as your application data plane.
Okay, finally, let's look at updates, giving more flexibility in core infrastructure and really streamlining the developer experience. I'm particularly excited by some of the quality of life improvements here.
Yeah, the theme here is definitely providing more specialized compute options tailored for specific jobs, always improving performance, and crucially, making things like infrastructure as code and local development more intuitive and, well, less error-prone.
Apple developers, listen up. Amazon EC2 M4 and M4 Pro Mac instances are now generally available. This feels like a big step for doing Apple development in the cloud.
These instances are absolutely ideal, yeah, for building, testing applications for Apple platforms, iOS, macOS, visionOS.
Right.
The performance gains are pretty notable. M4 instances give you up to 20% better build performance than M2. M4 Pro up to 15% better than M2 Pro.
Okay.
They've got 10-core or 14-core CPUs, 10-core or 20-core GPUs, and a new 2 terabyte instant store volume per dedicated host. That means low latency storage for better caching, build, test performance.
So what's the real impact?
The insight is that this lets development teams truly migrate those demanding build and test workloads to AWS. They can run significantly more tests in parallel, dramatically speed up their CI/CD pipelines for Apple stuff, and ultimately get products out faster.
And AWS keeps expanding its Graviton offerings, right?
Yeah.
And bringing specialized instances to more regions. We're seeing updates for EC2 IEG, REG, C6s, and even Elasticatch M7G, R7G nodes. It's a clear commitment to specialized, cost-effective compute.
It is indeed. And these updates really highlight how AWS's compute portfolio keeps maturing. So for storage-heavy workloads, the EC2 i8G instances, that's Graviton 4 and Nitro SSDs, they're now in US East Ohio.
Okay.
They offer up to 60% better compute performance, 65% better real-time storage performance per terabyte compared to i4G, and significantly lower I/O latency.
And for memory.
For memory-intensive stuff, R8G instances, also Graviton 4, are now in AP Osaka and Canada Central, delivering up to 30% better performance than the Graviton 3 ones. Ideal for databases, in-memory caches. C6 instances, those use 3rd-gen Intel Xeon for network-optimized apps. They're now in AP Thailand, offering up to 200 GBps bandwidth.
Yeah.
And in Elasticache, the Graviton 3-based M7G and R7G nodes are expanding to lots of new regions, giving improved price performance, like up to 28% increased throughput for Redis OSS on an R7G.4x large node.
So the big picture.
The overarching insight is this clear trend: specialized, high-performance, cost-efficient compute tailored for different workloads, letting architects really fine-tune their infrastructure for the best price performance.
Okay, infrastructure as code fans using AWS CDK.
Yeah.
There's a new preview feature. CDK Refactor. I distinctly remember one very long night trying to rename a core resource in CloudFormation without, bringing down production. It felt like open heart surgery with a butter knife. How does CDK Refactor save us from that nightmare?
That's a perfect analogy, and it's exactly why this is such a significant update for managing infrastructure that evolves over time. CDK Refactor enables safe infrastructure refactoring.
Safe how?
You can now rename constructs, move resources between stacks, reorganize your CDK apps, while critically preserving the state of the deployed resources.
Preserving state, that's key.
Exactly. Historically, those kinds of changes risk replacing existing resources because the logical IDs changed. That's the nightmare scenario you described.
Yep.
CDK Refactor uses CloudFormation's underlying refactor capabilities, but with automated mapping. It lets you confidently make architectural improvements like breaking down monolith stacks or upgrading constructs without needing complex migrations or risking downtime.
So it makes IAC more evolutionary.
Precisely. The insight is that this is truly transformative for IAC maturity. It enables evolutionary architecture without that constant fear of demolition.
Okay, for local serverless development, AWS has launched a LocalStack integration right inside Visual Studio Code. This seems to tackle a really common developer friction point.
It absolutely does. And it simplifies local testing and debugging significantly. Developers can now connect to a LocalStack environment straight from their VS Code IDE. No manual config, no code changes needed.
And it emulates the services locally.
Right, directly emulating AWS services like Lambda SQS, API Gateway, DynamoDB. The insight here is all about accelerating your serverless development cycle.
Yeah.
You can test and debug Lambda functions, their interactions with other AWS services, all in a local emulated environment, all within your familiar IDE. Faster iteration, fewer surprises when you deploy to the cloud, much smoother inner development loop.
Nice. Okay, finally, for data scientists, developers working with graphs, Amazon Neptune Analytics now supports NetworkX as a graph store. This feels like a powerful bridge between worlds.
It's precisely that, a bridge. Between local Python development and scalable graph analytics in the cloud, developers can keep using the familiar NetworkX APIs they already know, but automatically offload the heavy graph algorithm workloads to Neptune's scalable high-performance analytics engine.
So when the data gets too big for local.
Exactly. When your datasets grow beyond local limits, you don't have to refactor all your code or learn entirely new systems. The X-Neptune integration handles the data modeling, the zero-ETL data movement, the infrastructure management.
Right.
It'll even provision and tear down a Neptune analytics instance on demand. for a cost-effective, sort of serverless-like experience. It really democratizes scalable graph analytics, removes a big barrier for Python developers.
Wow, what an incredible sprint of innovation just this
Yeah.
week. I'm really struck by the synergy, between raw power and developer workflow improvements.
Yeah.
From supercharging AI models with P6B200s, optimizing workflows with Amazon Q and CDK Refactor, to shoring up network security with CloudFront ECDSA and GuardDuty S3 updates, plus expanding compute with new Mac and Graviton instances, AWS just keeps delivering.
These updates, taken together, they really highlight this consistent push
Right.
towards greater efficiency, better security, and more flexible developer-friendly tooling across the board. For you, the technical professional listening, it means more power, more control, and more opportunities to innovate with less operational drag, letting you focus on solving those unique business problems.
So, what stands out most to you from all this? How might these new capabilities influence your next project, or maybe spark a completely new solution? I'm already thinking about how CDK Refactor could simplify a big refactoring project I've been putting off.
Huh. That's the beauty of it, isn't it? As you think about these advancements, consider how you might combine them.
Yeah.
Like, imagine leveraging the improved performance and cost efficiency of Graviton for your AI inference workloads, secured by those expanded GuardDuty capabilities that now cover your massive data lakes. And all that infrastructure managed safely and iteratively with the new CDK Refactor command.
Interesting combination.
The true power often lies not just in one update, but in the synergistic effect of all these continuous innovations working together.
Absolutely. Well, we hope this deep dive is giving you a solid head start on understanding the latest from AWS and maybe spark some new ideas. Keep learning, keep building,
Like innovating.
and we'll catch you on the next deep dive.